morning, class. Today is Wednesday, and we have taken our big reading book story for today. So make sure you get your name at the top. As we read big ideas from nature, remember that this is an expository text. So we're looking at the text features. Remember, we talked about main ideas and key details this week. So pay attention to what you think the main idea of different sections are. We're on page 258. Big Ideas from Nature by Adrian Mason. Our essential question is, what ideas can we get from nature? Read how ideas from nature inspired new inventions. Top of page 259. Sometimes a sticky situation can lead to a great invention. In the 1940s, George de Mestral went for a walk with his dog. Along the way, George's pants and his dog's fur caught tiny seeds called burrs. George was curious. Why did the burrs stick so well? He looked closer. The burrs were covered in tiny hooks. George used this idea to invent a two-sided fastener. It had hooks on one side and loops on the other. Today, these hook and loop fasteners are used on everything from shoes to spacesuits. Think about Velcro here. Okay, so if you look in your book, you'll be able to see really closely this picture. It looks very similar then to the idea that Mestral came up with, where Velcro has those hooks on the top and then all those loops on the bottom, and they stick together so it can hold together a shoe or everything to spacesuits, our author says. Look at this text feature. We've got the idea here, and then this caption helps us. Observing how burrs stick to cloth and fur inspired one inventor to create a new fastener. Those sticky burrs gave de Mestral a great idea. Nature provided a model that George could imitate. Copying, or imitating, designs from nature is called biomimicry. Bio means life, and mimicry means to copy. Okay, a lot of times those science words you can break apart into their parts to figure out what they mean. So bio means life, so biology is the study of life. Mimicry then means the same thing as copy, so copying nature is biomimicry. From owls' sharp claws to elephants' bendy noses, nature is full of models. We can learn from each other. Top page 260. Observing nature gives us new ideas for things. George de Mestral didn't set out on his walk thinking he would create a new fastener, but by being curious and observant, he did just that. Nature did first. This is on page 260. Designers often start with a problem. They may look for solutions in the natural world. Nature has been making and testing designs for a long time. Nature often has the answers to questions that people ask. More than 100 years ago, the Wright brothers, Orville and Wilbur, wondered how to fly. For an answer, they watched birds, the flying experts. Watching birds gave them ideas on how to design airplane wings. While birds' wings are not identical to plane wings, they both can fly. The Wright brothers built an airplane in 1903. It was the first to lift up, up, and away. So here, the inspiration is this eagle, and then we've got another inventor that watched birds too. Leonardo da Vinci was an artist and inventor. He lived more than 400 years ago. He looked at birds' wings and then drew plans for many different flying machines. Next page, we're going to talk about smart shapes. Here at the top, we've got the inspiration, this fish, and the idea, this car. Let's read about it. Fish and cars share a problem. It takes energy to move a fish through water and a car through air. Fish get energy from food. Cars get it from fuel. To create a new fuel-saving car, designers studied the shape of fish. They found that the boxfish's square shape was streamlined. This means that the fish slips through the water without wasting energy. By making the new car's shape similar to that of the boxfish, they created a car that saves gas. The car's frame is also similar to the fish's skeleton. The metal frame is thick in some places and thinner in others, just like fish's bones. This saves on materials and puts strength where it is needed most. Once again, we've got this caption up here. Watching fish gave car designers a new idea for a car's shape. Energy savers. Air conditioners keep buildings cool. The shape of a building can also help. In Africa, termites gave builders an example of a self-cooling structure. Holes at the bottom of termite mounds catch the wind. The air rises through tunnels and flows out the top. The termites designed an effective way to cool a structure. The builders borrowed their ideas. During the day, fans on the first floor blow cool air into the building. The air rises and flows through chimneys on the roof. The design saves money and energy. So you can see that building in Africa. They've got all these mounds. This mound that termites use to stay cool, that's kind of like what they're using in that building. Next, we've got a grasshopper. Master movers. You can't travel to Mars, but a robot can. Robots can explore places that are not safe for people. Robots can't walk, but they still have to travel over dips and bumps. Sometimes they get stuck. Designers are working on a robot called Joelbot to fix the problem. The name Joelbot combines the words jump and roll. The Joelbot can do both. The super spring of grasshopper legs gave designers their idea. Once again, that caption, the grasshoppers and the robot Joelbot can both jump. Next, we've got tunnel makers. It's on page 264. More than 200 years ago, an engineer was trying to drill a tunnel under a river, but each attempt failed. The walls kept falling in. Then he saw how shipworms bored through wood. The animal uses a tough shield to drill. Then it builds a hard tube along the tunnel walls. What a great idea! The engineer copied the shipworm to build the Thames Tunnel. As he drilled, workers lined the tunnel walls with bricks. So you can see the shipworm here, how it's kind of boring holes to make tunnels, and then the inventors copied that as well. Mixing new materials. Got gecko and then this idea. Tiny hairs on a gecko's foot help it climb walls. It can cling to ceilings too. Scientists studied gecko feet to create a bandage with bumps. The bandage is so sticky it can even attach wet surfaces, like a human heart. Okay, so this bandage is something that helps doctors. Got the idea from geckos. Working together. Birds fly in flocks. Fish swim in schools. They can do this without hitting one another. Cars move in large groups too, but often they crash. Today, car designers are learning from locusts. They study how insects travel together safely. One day, you might drive a car that sees the cars around it. Now, this technology is actually already starting to happen. If you've seen one of those cars that on the side, the light lights up on the mirror, when a car is by, that's because that technology is kind of detecting that there's a car there. There's also cars that, see how this car is driving in a lane? That if a car comes closer to the lane line, it'll self-correct and move it back. So technology is getting better and better every day as people study the world that God created and find ideas from it. Learning from the experts. Biomimicry shows that ideas that work for nature can work for people too. It makes sense. Need a material that is strong and stretchy? Learning about spider silk would be a good place to begin. Spider silk is one of the strongest fibers in nature. It is as flexible as an elastic band and strong like steel. Need a type of glue that will harden in salt water? What do the sea creatures, barnacles, and mussels use to stick to rocks? Maybe nature already has a plan or a recipe that people can use. Observing how nature works also shows us ways to help the planet. Nature does not waste materials or energy, and natural designs do not pollute the air or water. Learning new things while protecting Earth's resources, that's an idea worth copying. You can see here the inspiration of the spider, and the idea was a cloth that was woven from silk that spiders use to spin webs. Okay, that's the end of our story for today. You've got a couple questions here. Now, remember, when I ask you these questions, I'm asking you to do your best work on it, okay? So a lot of us are sometimes writing down one word or just skipping a question that we don't feel like doing. That's not correlating to very good grades in the grade book, okay? Remember, all of the questions that I ask you are designed to help your brain build more connections and help make things easier for you, okay? So make sure you're doing your best on all of these assignments. Number 1, how do you know that Big Ideas from Nature is expository nonfiction? How is it expository nonfiction? Well, it's giving us information about how inventors use nature to inspire them. And then identify the text features. You just write them in a little box. So we had pictures, captions, headings, Number 2, what's the main idea of this article? What's the main idea? Well, we could probably use this, right? That inventors use nature to inspire them. And then for a key detail, just pick one of those inventions that we read about. Then you've got 2 more questions. Number 3 says, find the word inspiration in the photograph label on page 259. What is the root word of inspiration? What do you think inspiration means? And then number 4, write about why page 263 has the heading Master Movers. Explain what details the author chose to go with the heading. When you're done, go ahead and put this in your Wednesday folder. Thanks for doing your best work. Line 6 and 7 here. 1, 2, 3, 4, 5, 6, 7. So why not a vertical whirling winding bug that hops like a cricket crossing a rug? Okay, so he's comparing the helicopter to a cricket. All right, so for number 3, compares the helicopter to a cricket. Then in number 4, reread ornithopter. That was the second one. Use details to explain what the narrator thinks about the ornithopter. Do you agree with the narrator's point of view? Okay, so I want you to go back, reread the second poem, and explain what the author thinks about the ornithopter there.